All right, welcome to your next lesson on algebra. We've got some learning for you today. What we are learning today is that sometimes in our algebra, when we've got a bunch of terms all in a row in an expression, you should know what a term is in an expression now from our previous lesson, that when you've got a bunch of algebra all together in an expression, sometimes you can add and subtract the algebraic terms together, and sometimes you can't. So what we're going to do is we're going to learn when you can and can't add your algebra together, and what that means for us going forwards. So to be successful in today's lesson, the first thing you'll have to know is what a like term is, because like terms are the algebraic terms we can add together. Once you know which ones you can and can't add together, can you actually add and subtract them? So are you okay with your numbers? You've got your calculators at home if you're not. And what our goal will be through all of this unit is to make our algebraic expressions as simple as possible. So can you make your answer as simple as possible? So what we've just got over here is the most basic example of what a question like this would be. I have an A plus another A. What does it equal? We'll find out. Okay, so you will have seen this in your Year 8 and Year 7 algebra lessons, but let's just remind you of when you can and you cannot add together your algebra. So we're working with like terms today. So like terms are algebraic terms in our expression that have matching variables. You would have remembered from a previous lesson that your variables are your letters in your algebra, and they can have matching powers as well. So each letter has to have a matching power in the other term as well. As long as your letters and your powers are the same, your variables and your powers, it doesn't matter what number's out the front. Okay, so what I have here is three examples of things that are all like terms. They're all the same thing in terms of our algebra. So what that means is we're going to be allowed to add them together. So the reason they're all like terms is when I look at them, they've all got the same combinations of their letters and their powers. So this first one, the number 5 is irrelevant. The number 5 just tells me how many of my thing I've got. It's really just helpful for you guys if you just view your algebraic variables, your letters as just things, it's just objects. The number at the front is always just how many of that thing you've got. Okay, so in this case, an a squared next to a b is an object, it's a thing, all right? It's a square apple and a banana in a bowl, I don't know, and you've got 5 of those things. This next one next to it looks different but is the same as well because it has an a squared and a b next to each other. All right, they're probably in the wrong order. They're still all there in the term, so that means this matches that. And even though there's a minus 200 out the front, it's a bit of a funky number compared with 5 and 3. It's still got an a squared and it's still got a b, so these three things are all like terms. What I've got down here, I'll just move my cross out of the way, is something that isn't a like term with these ones here. It has an a and it has a b, but the b is squared this time, not the a. So a b squared with an a is different than an a squared and a b, so we wouldn't be able to put this term here together with these ones here. Okay, they're our like terms. They're what we're going to be working with today. So a very simple exercise here to make sure we're all on the same page as each other. Usually I'd get one of you guys to walk up the front and grab the smartboard and drag these around with your finger and put them in groups. I'll do that for you. We're just trying to match up all these like terms, the things that can go together. So again, I'm just going to remind you that the number at the front doesn't matter. Whether it's a negative or a positive, doesn't matter. Whether it's a 4 or a 3 out the front, doesn't matter. All we're looking for is the same combination of letters and the powers on those letters. So this one here is really a term that's all about letter Y. I've got minus 3 of them. So a like term for that one would be this one, positive 3Y. Right, they're a group, and I can find another one that matches that. It's minus 6Y. Okay, this one almost looks the same, but it's the letters that are really important. This one has an X and a Y, so it's going to be its own group. Right, X and Y is different than just Y. There is no number at the front. That means I've got one of those things. To go with that one, we've got this one, X and Y, and positive 6xy, right? So there's another group. I've got my y's, I've got my xy's. Xy squared is different, right? This one has an x and a y, this one has an x and y times a y, or two y's together. So that's different. So those would be a group. And then we've got a group here with my y cubeds and my y squareds. All right, these are our like terms. So I can add these or subtract these together. I can put these together. I can put these together. I can put each group together within themselves. But I couldn't add this one with this one, for example. They wouldn't go together. Okay, so it's all about knowing which things you can and can't add because they are the same thing. All right, now that we've established what a like term actually is, we can start to put this understanding into action by simplifying some questions. And this is where it's just a useful concept, all right? Whether we're using it algebraically in real life. We do use this stuff in real life all the time because we're just really grouping up things that are the same to make our interactions in the world simpler. So this is a guy, we'll call him, I don't know, Johnny Apple Guy. He likes apples, okay, and he's going to be working with apples today. This guy calls his apples the letter A when he writes it down because apple starts with A and the word apple is too long to write out, so he just uses the letter A. Algebra is really just all about having shortcuts for things that we might not know. So we're just going to use the letter A to represent an apple. Okay, and this guy here, Johnny Appleman, he went and he picked some apples. Okay, so in this situation, picked an apple, then he picked 5 more apples. Then he ate 3 of the apples that he picked. Apples are, tempting fruit, sometimes you just got to eat them. Then he picked 10 more apples, okay? And the question at the end of this is how many apples does Johnny Apple Dude take home? And it might seem like this is a question we don't even need algebra for this, really. But let's represent it algebraically to just show this concept of like terms. So the silliest way is to probably deal with our apples individually, the long way. Okay, so first he picked 1 apple. I put that one in red up here. Then he said he picked 5 more apples. So I've gone 1, 2, 3, 4, 5 more apples. And if you're keeping count at home, we're up to 6. Then he ate 3 apples. So I've done subtraction for that because those apples don't exist anymore. So he ate 1, he ate another one, he ate another one. Then he picked 10 more before he got tired and took his apples home. A shorter, more obvious way of doing that would be to say we picked 1A, 1 apple, then we picked 5A, 5 apples, then we ate the 3 A's, then we picked 10 more A's. But then what we're all about today is simplifying our questions and putting all of these together. So we're really just going 1 plus 5, take away 3 plus 10, and you probably figured this out right from the start, but that's 13 apples or 13A. Okay, so this is where like terms are useful. They take big, broad concepts and they let us just have one number at the end. And now the reason why that was such a nice, simple, easy example to start with was we were only dealing with one variable or just one object. We were only dealing with apples, right? It was all apples. We could put all of our apples together or we could just take away apples. But if our Johnny Apple face again goes out and for some reason there are bananas on this apple farm. He picks 4 apples, then he picks 3 more apples, then he gets bored with apples and he picks 2 bananas, then he goes back for 1 more apple. That would look something more like this, right? I've got 4 A's, 3 A's, 2 B's, and 1 A. And what becomes of that is all of our apples can be put together, but what you've really got to be sure that you don't do throughout this unit, and uh, it might seem obvious now, but we just see students over and over again try and just put everything together and put their apples and bananas in the same basket and end up with some kind of apnana kind of fruit. We don't want to do that. We want our apples to be done separately. Okay, our apples are not bananas. They can go together, but the bananas have got to stay separate, right? So our answer is going to have 2 parts to it. It's going to have our amount of apples, and then our bananas are different. It's a different letter. It's a different fruit. So that's part of our answer as well. Okay, all our apples made 8, and then we've still got our 2 bananas separately. Okay, so that's putting like terms together and keeping things that aren't like terms apart from each other. So what I would encourage all of you to do now is to get this slide here, everything that's in this particular screen, and this should be added to your glossary underneath all of your other glossary terms. This is usually what we put in there just to remind you guys of what you can do with like terms and adding and subtracting when it comes time to do a test on this. So we can add and subtract terms only when they're like terms. Okay, so let's just quickly run through these examples so you can put them in your glossary as well. So if I have 1 N and another N, 1 jar of Nutella and another jar of Nutella, I will have 2 jars of Nutella, right? If there's no number at the front of your variable, that means there is one of them, right? These have a coefficient of 1, and 1 plus 1 is 2, right? So then, again, same variable, 3 N's plus 4 N's. Just add the coefficients together, that's 7 N's. We get back to our apple and banana situation. You cannot add apples and bananas together, so you wouldn't be asked to simplify this because you can't simplify it. A plus B is always just A plus B. And in the same vein as that, 3A plus 4B remains 3A plus 4B. They can't go together. Your answer's allowed to have 2 parts to it or 2 terms in it or more than 2 terms. You've got to keep every term separate. Okay, this is a big long string, but again, we can just put them all together. You've got to handle your negative numbers or check it on your calculator if you're stuck. So negative 3 plus 4 takes me up to 1. Take away 1 puts me at 0. And then adding 5 leaves me with a total of 5 n's. Then we've got a situation here where we've got y's and we've got n's. We've got two different variables. What I'd encourage you to do is to write your question out, circle your like terms, make sure you're capturing the negative or the positive in front of it, because that's the coefficient, that's how many of the thing you've got, and then you can start to put them together. So if I'm dealing with my y's first, 5 take away 1 is 4, and take away 8 more leaves me with negative 4y's. And then I can deal with the second part of this, which is the n's, where I've got 6 of them, take away 3 of them. Okay, and 6 take 3 is positive 3, so we're going to put a positive in front of it, positive 3n. Right, they should go next to each other, but I'm running out of space. Okay, so this is a perfectly good slide to have in your glossary that'll help you down the track. Okay, so we're just going to do a few more examples to finish this off, ranging from pretty easy to a bit more difficult, closer to your Year 9 standard. But what I'd just encourage you to do is, no matter how long your algebra gets, how many things are in a row, you could have a whole page full of algebraic terms, all lined up with pluses and minuses. Your two-step process is always the same. Decide whether you've got like terms, whether there are things in your expression you can add together, and then just do it. Add them or subtract them from each other. So here, dealing with zebras, I've got 5 zebras and 3 more zebras, right? We know that 5 plus 3 is 8, and these are like terms, so we put them together. Right, 7t take 10t. It's time to remember that negative numbers do exist, right? We can go lower than 0, right? So 7 take away 10 is not 3, it's negative 3. And that negative 3 is negative 3t's. Okay, so this one, we've got powers involved now, but that doesn't matter. A b squared is just a thing, right? It's a square banana, right? It's a square brick. Okay, a b squared is just a thing, just like a b is a thing. We're just asking how many of that thing you've got. So if I start with 1 b squared, right, there's a 1 there. We just don't bother writing it. Take away 6 of them. 1 take away 6 is negative 5. And the thing I'm working with is a b squared. All right, in this example, again, we've got like terms. They're just written differently. Both of these terms have a g and a k inside them. Okay, just they're in the wrong order. We prefer to write things in alphabetical order if we can, so when we write our answer, we will. But because we've identified that they are like terms, 8 take away 6 is pretty elementary. There it is. And we'll go G, and we'll go K, and that question's done. Then with the last one, let's just go looking for like terms. Okay, so this one has a h squared and a y as the variables in the first term. I've got to go looking for anything else that has a h squared and a y in it. And there are actually no like terms for this particular one. Okay, so I'm not going to do anything with it. It's part of my question, so it's part of my answer, but I'm not going to be adding or subtracting any of these other objects with it. All right, we'll move along the line. All right, I'm dealing with h's and y's with no squares on any of them. And I do have a matching one over here. This one has a h and a y in it. So I've got to know what negative 5 plus 10 is, or what 10 take 5 is. So that leaves me with 5 of this particular one. Okay, so I've got 5. I'm going to go hy because alphabetical order is good. And then this is my last term, so there's obviously not going to be a like term for it. It needs to be part of my answer as well. 3y squared h. Okay, so we identified the only pair of like terms that were in it, and we put them together. Okay, so that's the end of this lesson. There'll be some work for you to go through related to like terms on Google Classroom, and then there'll be some mathematics for you to do as well to round out your first week of remote learning.